Point 6. In the second half of Chapter 7, we've been looking at a major concept in Algebra 1 and Math Beyond, and that's factoring of polynomials. That is the breaking down of higher degree polynomials into its smaller degree factors that when multiplied together would get you back that original polynomial. Today we are looking at factoring another type of trinomial. This is again to a second degree trinomial. However, this time our leading coefficient's not going to be equal to 1. So one key thing to remember when you see this situation where your leading coefficient's not equal to 1, look and see if you can factor out a greatest common factor first. If there is one, factor that GCF out first, then see if you can factor the remaining polynomial further. Let's take a look at this first example. Factor each of the following by factoring out the GCF first. So as I look across, I see that my leading coefficient is not equal to 1. However, all three of these terms could be divisible by 5. So let's factor out a GCF of 5. Now I'm left with x squared plus 3x plus 2. Now, inside the parentheses, I have a trinomial, second degree, with a leading coefficient equal to 1. So similar to what we did yesterday, we're looking for factors of 2 that combine to be positive 3. Well, the only two factors of 2 are 1 and 2, and they do add up to equal 3. So we can factor this further into x plus 1 times x plus 2. Now, don't forget to carry down that GCF of 5. That goes out in front as well. So here is our full factorization of our original polynomial 5x squared plus 15x plus 10. Likewise, in 1b, I see that I can factor a 3x out of each one of these to each one of these terms in this polynomial. When I do that, I'm left with x squared plus 5x plus 6. Now, I always have to ask, can I factor this trinomial, this with a second degree, down into some smaller factors? And so this has a leading coefficient equal to 1, and so I can take factors of 6 that combine to give me positive 5. So the factors of 6 that combine to give me 5 are 1 and 6, or 2 and 3. And since both of these need to be positive, I see that it's got to be 2 and 3. So my final factorization then would be x plus 2 times x plus 3 times that original GCF that I factored out, 3x. So in the end, I can factor that polynomial by first pulling out the GCF and then factoring that trinomial further into x plus 2 times x plus 3. All right, so what happens if we don't have a greatest common factor that we can pull out first? There's a couple of strategies that we can use to factor the polynomial. The first strategy I want to show you is known as Kung Fu. All right, so we're going to get very serious. In Kung Fu, there are two steps. You kick and you chop. All right, so let's talk about this and how this works. We're going to first take a look at our trinomial. We got 4x squared plus 13x plus 3, and we see that the leading coefficient there is not equal to 1. So what we're going to do is we're going to take that 4 and we're going to kick it to the 3. So kick is multiplication. All right, so we're going to multiply the 4 to the 3, and we're going to rewrite our polynomial as x squared plus 13x plus 12. Now keep in mind that 12 came from multiplying the 4 and the 3. All right, now I have a trinomial where my leading coefficient is 1. So I'm going to factor this the same way I did in the previous lesson, taking factors of 12 that combine to be positive 13. So I'm going to list that as 1 and 12, 2 and 6, or 3 and 4. Well, since both of these need to be positive, I know that 1 plus 12 is going to give me 13, and those are my two factors. So I'm going to write my factors as x plus 1 and x plus 12. Now my next step is the chop. And when we chop, what we do is we divide. Since we originally started off by writing this polynomial by multiplying 4 to the 3, I now need to divide both of those numbers by 4. All right, my final step then is to simplify. So when I simplify, I look at my factors here, and I see I have x plus 1/4, and I have x plus 3. Now, it's mathematically impolite to write a factor as x plus 1/4. So what I'm going to do is I'm going to rewrite this by swinging this 4 in the denominator out here in front of the x. So my two factors are 4x plus 1 and x plus 3. And this is the final factorization of my original polynomial, which was right up here, 4x squared plus 13x plus 3. And if you want to check it, you can redistribute those and remultiply them back together, and you will see that you get 4x squared plus 13x plus 3. So that is the Kung Fu method. We'll do one more of those here just to get some extra practice. All right, let's take a look at B. In B, we see that we have 6x cubed minus 14x squared plus 4x. Aha, I see that I have a GCF here that I can divide out. I'm going to divide out a 2x, and that's going to leave me with 3x squared minus 7x plus 2. All right, now inside the parentheses, I still don't have a trinomial with a leading coefficient equal to 1, so I am going to use the Kung Fu method, which means to kick the 3 to the 2. And I'm going to rewrite that polynomial as x squared minus 7x plus 6. Okay, I want factors of positive 6 that combine to give me negative 7. All right, this is an interesting case here. If I have factors of a positive number that combine to be a negative number, then both of my factors must be negative. So, for example, negative 1 and negative 6, or negative 2 and negative 3. All right, my factors here need to be negative 1 and negative 6. So I'm going to write that as x minus 1 times x minus 6. That's my kick step. Now I'm going to chop. And if you remember, I originally started by kicking the 3 to the 2. So now I got to chop those two numbers by 3. And finally, I'm going to simplify. This becomes x minus 1/3 and x minus 2. Well, since I cannot write x minus 1/3, I'm going to kick this 3 up here in front of that x, and my factors become 3x minus 1 and x minus 2. Now don't forget your original GCF that you factored out. This is also part of your factorization. So your final 3 factors here are 2x, 3x minus 1, and x minus 2. Okay, let's go on to the second strategy, which is called split the middle. Now, you may prefer this method over the Kung Fu method, and we'll practice more in class together as well. So with split the middle, we are going to write our first term, 2x squared, and then we're going to leave the middle open, and the last term out here is minus 7. Okay, now the two terms that come here in the middle are going to be found by taking 2 times negative 7. Okay, that's going to be negative 14. So I want factors of negative 14 that combine to give me negative 5. So think through your factors of negative 14. They have to be different signs. So 1 and 14 or 2 and 7. Well, we can get negative 5 by having a positive 2 and a negative 7. So these are my two factors I want to put here in the middle. So because this is a 5x in the middle, I'm going to make this say positive 2x and minus 7x. Do you see how now if we were to combine these, we would have negative 5x? So what we've done is we've taken a 3-term polynomial and we've split the middle here by rewriting that middle term as the sum of 2 other terms. Okay, from here, we are now going to take the front half and factor out the GCF. The GCF of 2x squared and 2x is 2x, and I'm left with x plus 1. And now we're going to do the same thing to the back two terms. Factor out the GCF. The GCF of negative 7x and negative 7 is negative 7, and I'm left with x plus 1. So what you should see now is that you actually have your factors. Your factors are 2x minus 7, and the other factor is x plus 1. So we are left with 2x minus 7 and x plus 1 are the final factorization of our original polynomial, 2x squared minus 5x minus 7. So that's the split the middle method. We'll try that one more time here, splitting the middle. And it is kind of a difficult concept. So one way to start is by taking 12x squared, and you're going to write it down here. And then you're going to leave your middle two terms open. And then you got your minus 5. In the middle two terms, remember, are found by taking 12 times negative 5. That gives you negative 60. We're looking for factors of negative 60 that combine to be positive 17. So they have to be of different signs, and they got to combine to be positive 17. So I'm going to jump right to a positive 20 and a negative 3. So I'm going to, doesn't matter which one I write with which, I'm going to write it as positive 20x minus 3x. And you can see how if you were to combine positive 20x and negative 3x, you'd end up with positive 17. Okay, so let's factor out the GCF of our first two terms. What divides evenly into 12x squared and 20x? And that would be 4x. And when I divide that out, I'm going to have 3x plus 5. Next, we're going to factor out the GCF of negative 3x and negative 5. Well, there really is nothing except for negative 1. And when I factor that out, I'm left with 3x plus 5. And once again, you can see that your two factors are 4x minus 1 and the remaining 3x plus 5. So the final factorization here is 4x minus 1 and 3x plus 5.